You've seen it, right? It feels like one day AI was just a clunky assistant on our phones, and then bam! Overnight, it's writing code, it's creating incredible art, it's holding conversations that feel real. This massive leap has left a lot of us scratching our heads and asking one big question. Seriously, why now? What flipped the switch? What was that fundamental shift that unlocked all this incredible power? Well, the answer isn't some single magical algorithm that someone dreamed up. It's actually a really powerful concept that completely changed the game. So, let's dive in. The secret, the real reason for this explosion, is an idea called deep learning. And it all boils down to one simple but unbelievably powerful principle: the ability to scale. Okay, check this out, because this graph right here, it basically tells the whole story. For decades, the old school AI algorithms would just hit a wall. You see that plateau? You could shovel more and more data at them, but their performance just flatlined. It was like their brains were full. But look at the lines for neural networks. That's the engine of deep learning. The more data you give them, the better they get. The line just keeps going up and up. There's no wall. So this is the absolute game changer. We finally found a recipe where tossing in more data and more computing power predictably leads to better and better performance. This single scalable insight is what's driving billions of dollars of investment and sparking the AI revolution we're living through right now. And you know, this story perfectly captures the spirit of it all. The very first GPU server used for this kind of work wasn't in some giant corporate data center. Nope, it was built by an undergrad at Stanford in his dorm room. It just goes to show you how a single idea, even in a simple setting, can literally spark a global transformation. Okay, so let's clear something up. We hear all these buzzwords thrown around, right? Machine learning, deep learning, generative AI. It can get super confusing. This simple map is going to show you exactly how they all fit together. Just think of it like a stack of building blocks. At the very bottom, you've got the foundation, computer science. On top of that, you have machine learning, which is this big idea of algorithms that can learn from data instead of being explicitly programmed. Now, deep learning is a really, really powerful type of machine learning that uses things called neural networks. And then right at the very top, you have generative AI, which is built on those deep learning models like the transformer architecture you've probably heard so much about. See? Simple. And here's a little fun fact for you about the name. The core technology, neural networks, had actually been around for ages. But about 10 or 15 years ago, researchers kind of realized that deep learning was just a much better brand. I mean, come on, who doesn't want learning that's deep? Pretty smart, right? So today, the terms are used pretty much interchangeably, but you can't deny it was that rebranding that really helped the whole idea take off. All right, so if you actually wanted to get your hands dirty and build stuff with this technology, what does that really take? It's way more than just knowing about some fancy algorithms. It's a whole set of very practical, hands-on skills. The real work, the day-to-day, involves building these networks from the ground up, getting good with models like transformers for text, and, this is a big one, learning how to tune all the little knobs and dials on the model. These settings are called hyperparameters, and tweaking them is how you squeeze out every last drop of performance. And this quote just, man, it nails it. This stuff isn't just theoretical. Your practical skill at tuning these models, your intuition, can literally be the difference between a project working and it failing. Or, as he says, the difference between going home at 3 in the morning versus pulling an all-nighter and leaving at 7 a.m. It's a real craft. But honestly, beyond all the code, the single biggest thing that separates successful projects from failures is just having a disciplined process. You know, inexperienced teams might randomly decide, hey, let's spend the next 6 months collecting more data because they read an article. An expert could have told them on day one that that was the wrong move. Knowing what to work on and why, that's the real 10x skill. So, what does this all mean for the future of work, especially for people who build software for a living? Well, the game has definitely changed, and there are some new rules to play by. This is the million-dollar question, isn't it? It's on everyone's mind. We're even hearing some very senior, very smart people telling young folks not to learn how to code because AI will just do it all. But honestly, that might be some of the worst career advice ever given. Just think about it for a second. When we went from clunky punch cards to keyboards, did we get fewer coders? No, we got a ton more. When we went from super complex assembly language to modern languages like Python, did fewer people code? No, way more people started building things. Every single time the barrier to entry gets lower, more people become builders, not fewer. This time is no different. So here's the bottom line. The demand for the old way of doing things is falling. A software engineer who doesn't use AI is becoming like a coder who insisted on using punch cards. But the demand for people who can leverage these new AI tools, guided by a deep understanding of the fundamentals, that demand is absolutely skyrocketing. This analogy explains it perfectly. One expert was trying to generate images, but all he could think to type was, please make pretty pictures of robots for me. But his collaborator, who knew art history, who understood different genres, palettes, and artists, he could speak the language of art to the AI. He could give it precise expert instructions and get back absolutely stunning results. And that right there is why fundamental knowledge is your new superpower. It lets you go way beyond just basic prompting. When you understand how the computer and the AI actually work, you can speak their language. You can give them expert-level instructions and get back results that someone without that foundation could never, ever achieve. We are at this incredible moment where an individual's ability to create is higher than it has ever been in history. The cost and time it takes to try a new idea, to build a prototype, has just plummeted. So that leaves us all with one final and pretty empowering question. With these new tools and this new power at your fingertips, what are you going to build?